Table and graphs show a more complete picture of the temperature changes on the same winter day. The function T gives the temperature in degrees Fahrenheit, h hours since noon. Find the average rate of change for the following intervals. Explain or show your reasoning. Between noon and 1 p.m., between noon and 4 p.m., between noon and midnight. Okay, so there are a few strategies that we can use. We can use hourly changes. We can use overall changes. And we can use slopes. So I'm going to try to do one of these for each problem. So let's do hourly changes for this one. Hourly changes. Let's do slope for this one. And let's do overall changes for this one. Okay, so let's find the average rate of change for between noon and 1 p.m. Okay, so these values right here are basically x and y values, but we can represent them as h and t of h. So the point 018, that's right here, and the point 119, that's right here. So we can actually calculate the slope right here in between those two values, and that's going to be our change, average rate of change. So the way that we calculate slope is we take one y value and subtract another y value, and we divide that by one x value subtracted by another x value. So here are my 2 points. So I'm going to do my y values first. So 19 minus 18. And on the bottom, I'm going to subtract my x values, 1 minus 0. So this is going to give me 1 on the top and 1 on the bottom. So my average rate of change for the first one should be 1. Okay. For between noon and 4 p.m. Okay, so another strategy that we can use, I'll do this one in red, between noon and 4 p.m. is we can figure out how much did it change every hour and then add them all up. Okay, so here's the first change, here's the second change, here's the third change, here's the fourth change, and then we can add up all of those changes and divide by how many changes there were. So from noon, it was 18, and then from 18 to 19, it changed 1 degree. So that's 1 degree. And then from 19 to 20, it changed 1 degree. From 20 to 20, it changed 0 degrees. And then from 20 to 25, it changed 5 degrees. And that's going to be divided by how many hours we had. So our formula here is basically change per hour divided by number of hours. And we're doing this change per hour for all of the hours. Okay, so this is going to give us 1 plus 1 plus 5. So that's 7 divided by 4. We can represent that as a decimal, 1.75. So that's 1.75 degrees per hour. So I'll write that right here, 1.75 degrees per hour. Okay, and then the last one is we can do overall changes. So let's say between noon and midnight. So that's going to be from here to here. And it's very similar to finding slope, except instead of like using slope formula, we can just think about how many hours it changed overall. So we started out at 18 degrees and we ended up at 7 degrees. So that's a difference of 3 plus 8, 11 degrees, right? So it changed 11 degrees. 11 degrees. And then that's a distance of 12 hours. And since the temperature was dropping by 11 degrees, we'll make that a negative. So I'll put here, actually, let's do this. Let's do total change over number of hours. So our total change was negative 11 degrees. We're dividing that by 12 hours. And so we get negative 11 over 12, or that's approximately negative 0.92. And that's degrees per hour. Oh, and this is degrees Fahrenheit.